something has just happened on Mars. Something so impossible, so wildly out of line with everything scientists believed about the red planet that NASA and planetary researchers are now scrambling for answers. For decades, Mars looked like a dead world, a silent desert frozen in time. But new signals, unexpected seismic activity, and one stunning revelation beneath its surface have shattered that belief and forced humanity to confront a question we were never prepared to ask. What is Mars hiding? And why is it revealing it now? For most of human history, Mars was a symbol, a distant ember in the night sky, a world we assumed had long since gone silent. But the truth is far more complicated and far more unsettling. Mars has never been just a barren wasteland. Before it became the rust-colored desert we see today, it was a planet bursting with potential, shaped by flowing water, thick air, and geological forces that once rivaled our own world. Billions of years ago, Mars was warm enough for liquid water to move freely across its surface. Rivers twisted through canyons, shallow seas pooled in basins, and great lakes formed in the shadows of volcanic uplands. If you stood there then, the horizon would have looked strangely familiar. Blue skies, currents of water, and perhaps even the chemical building blocks of life drifting through ancient Martian oceans. Scientists now know this wasn't just speculation. Mineral deposits, dried riverbeds, and sediment layers all point to a time when Mars resembled early Earth far more than the frozen desert we see today. And on Earth, wherever there is water, life is never far behind. Microbes, bacteria, and strange, resilient organisms appear whenever conditions allow, even in places we once believed were sterile. So when researchers confirm that ancient Mars was covered in water, the idea of Martian life shifted from fantasy to scientific expectation. Not intelligent beings or towering structures, but simple organisms clinging to existence in an environment that might once have been perfect for them. But then something catastrophic happened. Around 3 billion years ago, Mars began losing its atmosphere. The protective blanket of air that kept its water stable started to leak into space under the relentless pressure of solar radiation. With each passing millennium, the air thinned, temperatures dropped, and the rivers that once carved the Martian landscape didn't simply dry up, they escaped into the void. What remained either froze at the poles or retreated underground. For decades, this explanation became the accepted story. Mars had water. Mars lost water. End of story. A neat, clean timeline that scientists believed tied up all the mysteries. But Mars has a way of resisting simple answers. New evidence has begun to break open that narrative. Seismic readings, unexpected geological signals, and anomalies detected deep beneath the surface suggest that the planet we thought was long dead may not be dead at all. Instead, it might still be active, still evolving, still hiding remnants of what came before. And if that's true, then everything we assumed about Mars and its ancient story becomes just the prologue. The real mystery lies beneath its scarred crust, waiting to be uncovered. While orbiters mapped the surface and rovers explored ancient riverbeds, NASA launched a mission unlike any other, one that wouldn't search for rocks, valleys, or minerals, but for something far more elusive, the heartbeat of Mars itself. The InSight lander touched down in 2018 on a flat, quiet plain known as Elysium Planitia. There were no dramatic cliffs or towering mountains nearby, nothing that would make headlines or inspire breathtaking photographs. That was intentional. InSight wasn't built to roam. It wasn't built to drill for samples or uncover relics of ancient water. It was built to listen. Beneath a small white dome, InSight deployed one of the most sensitive seismometers ever placed on another planet. On Earth, similar instruments reveal earthquakes, volcanic tremors, and the dynamic forces reshaping continents. On Mars, this sensor had a single mission: detect Marsquakes, subtle vibrations that could expose what lies deep beneath the crust. For years, the lander recorded faint tremors. Some came from meteorite impacts. Others were tiny adjustments in the crust, the slow settling of a planet cooling from the inside out. But on May 4th, 2022, everything changed. A seismic event shook the planet, a magnitude 5 Marsquake, the largest ever detected. Its waves rippled across the entire planet, circling Mars again and again for hours. Immediately, scientists mobilized. Something of that magnitude should have left a clear mark on the surface, a crater big enough to spot from orbit. NASA's fleet of satellites scanned every region where an impact might have occurred. Nothing. No crater, no debris, no plume of dust frozen in the thin atmosphere. The conclusion was unavoidable. This quake didn't come from above. It came from within Mars itself. And that revelation forced scientists to reconsider everything they thought they knew. When seismic waves move through a planet, they behave differently depending on the material they encounter. Solid rock slows the waves slightly. Softer sediments bend and scatter them. But fluids, especially water, alter their speed dramatically. So when researchers analyzed the seismic data from the May 4th event, they found something they never expected: a sudden dramatic slowdown of the waves deep beneath the surface. At a depth of 10 to 20 kilometers, the signature matched only one thing: a massive reservoir of liquid water. Not ice, not permafrost, liquid. The implications were staggering. According to the models, if this reservoir were somehow brought to the surface, it could cover the entire planet in a global ocean nearly a kilometer deep. In a world long assumed to have bled out its water to space, the discovery of such a vast underground ocean was nothing short of revolutionary. But even more shocking was what the discovery suggested about Mars's internal activity. A reservoir of that scale requires heat, pressure, and geologic processes still operating beneath the crust. Mars, it seemed, was not the cold, dead rock scientists once believed. It was still moving, still shifting, still alive in ways no one imagined possible. Theories rushed forward. Some proposed that ancient surface water had seeped downward as Mars cooled, filling underground fractures and porous rock. Others pointed to Earth's mantle, where minerals can trap enormous amounts of water within their structure, suggesting Mars might hold even more water than detected. But a more profound question began to surface. If water had retreated underground, could life have followed it? Mars's greatest mystery was no longer ancient. It was happening right now, beneath our feet. The discovery of a vast underground reservoir shook the scientific world, but the implications went far beyond geology. If liquid water still exists beneath the Martian crust, then one unsettling possibility rises to the surface. Life may not just have existed on Mars, it may be surviving there right now. On Earth, life has proven itself far more adaptable than anyone expected. We've found microbes thriving kilometers below the surface, sealed in water pockets, isolated for millions of years. They survive without sunlight, without oxygen, and sometimes in temperatures nearing 180 degrees Celsius. These organisms rely not on photosynthesis, but on chemical reactions between minerals and water, an energy source available even in the darkest corners of a planet. This is what makes the Martian reservoir so extraordinary. While Earth's deepest life has been discovered hundreds of kilometers below the surface, The potential Martian habitat may lie only 10 to 20 kilometers down, still out of reach for today's technology, but unimaginably closer than anything on Earth's scale. If water moved downward as Mars dried, it could have carried organic molecules with it. Microbial life, facing the collapse of the atmosphere and the freezing of the surface, might have retreated underground, following the last traces of warmth and stability. In that hidden refuge, insulated from solar radiation and shielded by kilometers of rock, life could have continued in silence. The idea is no longer speculation. Chemical signatures found in Martian meteorites hint at organic reactions. Traces of methane detected in the atmosphere suggest ongoing processes, biological or otherwise, and the seismic data from InSight indicates that Mars's interior is still active, still producing the conditions necessary for pockets of heat and liquid water. But accessing that reservoir poses a monumental engineering challenge. Drilling even a few kilometers on Earth requires colossal machinery, stable ground, and constant energy. On Mars, where temperatures plunge, dust storms rage for weeks, and communication delays disrupt real-time control, the challenge multiplies tenfold. Even companies on Earth, known for massive tunneling operations, would struggle to reach such depths on another world. Still, the discovery changes everything. Mars can no longer be dismissed as a dead, silent relic of ancient oceans. It may be a world hiding a deep, slow-beating pulse, one that has endured long after its surface froze. If life does exist underground, it would reshape not only our understanding of Mars, but our understanding of life itself. And perhaps the biggest revelation is this: Mars's story isn't over. It may be only in its next chapter. The revelation of a massive underground reservoir on Mars was a scientific earthquake, but it was only the beginning. Once researchers confirmed the seismic signature of liquid water, a new rush of questions erupted across the scientific community. Not just, is the water there, but what is it doing? And more importantly, what else might be down there with it? If Mars truly holds a hidden ocean, then the next mystery becomes the planet's internal engine. How is liquid water being maintained at such depths? Mars is smaller than Earth, losing heat faster. Many believed its core had cooled long ago, leaving it geologically inactive. But the seismic readings from InSight painted a radically different picture, one of a planet still shifting, still generating enough internal warmth to prevent an entire reservoir from freezing solid. That alone rewrites decades of assumptions. But the implications go deeper. A liquid reservoir interacting with rock produces chemistry, complex chemistry. On Earth, entire ecosystems thrive in similar environments, powered not by sunlight, but by interactions between minerals and water. Microbes feast on hydrogen, iron, sulfur, and methane-generating reactions in the dark. If Mars possesses even a fraction of this chemical interplay, it could sustain life far beneath the crust. But this new theory opened yet another possibility, one even more shocking. What if Mars's underground ocean is not just a relic of ancient water, but part of an active hydrological cycle deep within the planet? Some scientists theorize that pressure and residual heat could create liquid chambers that slowly circulate, fracture, and reform. In other words, Mars might still be evolving internally, its depths shifting with pockets of water that migrate and reshape the crust over millions of years. If true, the underground reservoir isn't just a pool, it's a system, a living system. Such a discovery raises another critical question. Could there be multiple reservoirs? Could the water extend farther than seismic readings have revealed? Current data suggests the possibility of interconnected networks, vast subterranean channels, pressurized lakes, and mineral-rich pockets that expand far beyond the initial detection zone. And where water flows, even slowly, life has more opportunities to spread. But reaching this hidden ocean is an entirely different challenge. On Earth, drilling into the planet's crust requires massive platforms, industrial equipment, and stable ground. The deepest humans have drilled, Russia's Kola super-deep borehole, barely reached 12 kilometers, and that took decades. On Mars, with gravity 1/3 of Earth's and an environment hostile to machinery, drilling even half that depth demands technology humanity hasn't yet developed. Dust storms would bury equipment, freezing temperatures could crack metal, pressure differentials could destroy any drill introduced to the subsurface, and the lack of infrastructure means every piece of machinery must be imported, assembled, and operated remotely. Still, none of these challenges diminish the significance of what lies below, because the discovery of liquid water at depth forces researchers to rethink Mars not as a dead world, but as a world transitioning, one still holding on to remnants of its ancient warmth and internal complexity. A world that may not be done evolving, but the greatest question of all remains hanging in the cosmic silence. If life exists in that underground ocean, what form would it take? Would it resemble Earth's deep biosphere, simple hardy microbes thriving on chemical gradients? Or could billions of years of isolation have produced something stranger, something adapted to pressure, darkness, and extreme mineral environments unlike anything on Earth? Such life wouldn't need sunlight. It wouldn't need an atmosphere. It wouldn't even need a surface. It could exist entirely in darkness, thriving beneath kilometers of rock, surviving off chemical heat and ancient processes still unfolding inside the red planet. And if such life exists, if Mars truly harbors survivors from its wetter, warmer past, then we are not just looking at another planet with a mysterious history. We are looking at a neighboring world that may be alive right now. This changes everything. It alters how we search for life. It alters how we plan future missions. And it redefines our understanding of what planets can become after losing their atmospheres and surface oceans. Perhaps the most astonishing realization is this: we have spent decades searching for life on the surface of Mars, when the real story, the real secret, was hidden far below our feet. The red planet has been whispering clues for years, and now, with the tools to finally interpret them, we are closer than ever to uncovering a truth that could change our place in the universe. The realization that Mars may still harbor liquid water deep beneath its surface has set off a chain reaction across every field of planetary science. This isn't just another discovery, it's a turning point. A moment when everything we thought we understood about barren worlds, ancient climates, and the limits of planetary evolution was suddenly forced into question. For decades, missions to Mars focused on the surface, craters, dust, sediment, and the faint echoes of water that once flowed freely. But now the focus is shifting. The real answers, the ones capable of rewriting humanity's understanding of life beyond Earth, lie underground, and reaching them will define the next era of exploration. The next generation of landers, rovers, and orbiters is already being redesigned with this discovery in mind. Engineers are debating new drilling technologies, heat-resistant machinery, and autonomous systems capable of surviving months beneath the crust. Some propose robotic penetrators that could burrow using repeated impacts. Others imagine nuclear-powered drills, melting their way downward like metallic comets. These ideas may sound futuristic, even impossible, But so did powered flight, lunar landings, and rover missions across alien terrain. What once seemed unimaginable has a way of becoming inevitable when the potential reward is this profound. Because if Mars truly hides a subsurface ocean, then it may also hide something far more extraordinary: life that has persisted for billions of years, evolving independently of Earth, adapting to pressures and darkness in ways that could expand our definition of biology. And if that is true, the discovery wouldn't just change science. It would change every assumption we hold about our place in the universe. But Mars isn't waiting. Its interior continues to shift, producing tremors that pulse through the crust like a distant heartbeat. With each quake, with each seismic whisper, the planet reveals a little more of itself, inviting us to listen, to interpret, and to dare to follow the evidence where it leads. Humanity now stands at the doorway of a world that may not be dead, but quietly alive. The coming decades will determine whether we can unlock its secrets, whether we can go deeper than ever before, whether we can bridge the gap between what we imagine and what we can actually achieve. One thing is certain: Mars has already begun telling a new story. A story not of a frozen relic, but of a planet still holding onto warmth, water, and possibly the last surviving echoes of its ancient life. And the world needs to see what happens next. Because if there is life beneath Mars, if something has endured in the dark all this time, then finding it would redefine not just the red planet, but the meaning of life itself. If you enjoy exploring discoveries like this, hidden oceans, seismic mysteries, and the search for life beyond Earth, make sure to subscribe. Your support helps this channel grow and brings even more cosmic stories to life. The universe is full of secrets. Let's uncover them together.